Good morning and welcome back. So today we are going to discuss the topic number system. So we are going to divide this topic into two parts. In the first part, we are going to learn what is what, like what we are going to cover, these kind of things. In the second part, we are going to practice. So before moving on, I would like to show you what we are going to cover here. So in today's class, we are going to cover like what is meant by number system, what are the classification of numbers, like rational, irrational, natural, all those classifications. Then divisibility rules. After divisibility rules, we are going to cover LCM and HCF. Later on, we are going to go to power cycle, then remainder cycle. Okay. And there are some problems where he will ask you to find out trailing zeros. What is meant by trailing zeros? Let us take 1000. How many zeros are going to be there in 1000? We are going to get 3 zeros. Those kind of problems. Now you may got the doubt. Okay, everything seems blank. What we are going to do after completion of the class. For that, what I did is I prepared a Word file for you. I will show you the Word file. In that, I have put everything that we are going to cover in the class. I will show you one by one. So whatever the definitions you want, okay, whatever the practice problems you want, okay, with examples. So in the PPT, we are going to focus on explanation part. So if you want to prepare later on, you can just download this Word file and you can read everything. See, whatever we are going to cover, every explanation and every method was mentioned here. Okay. So PPT is for me to explain you how you are getting the things. Then this is for your reading material. Both of them I will try to put in the description. Please download from there so you can read it on later on. Okay. So like power cycle, you can see reminder cycle also. I included each and every model along with the practice problems here. So once you are done with the class, just open it and you can just read the word file. So without further delay, let's get started. So now first, what are numbers? So simply saying those are like fundamental mathematical objects used for counting, measuring and labeling items or quantities. Now what is the purpose here? See, numbers are essentially for qualifying the world, such as counting items, measuring or ordering like this. So we are going to use, symbols like 1, 2, 3, 4. Those are nothing but symbols to represent those numbers. Now, the first thing we are going to learn here is classification of numbers. So here I have written. So the first classification here is, okay, total numbers can be divided into two parts. One is rational numbers and the second one is irrational numbers. Now, if I want to say simply, rational numbers means something you can write in the form of phi by q, like 1 by 2, okay, or again you can say 1 by 3, these kind of numbers. Then what about irrational numbers? Irrational numbers in the sense, first thing, you can't write them in a p by q form, and when you are getting the decimals, they are never going to end. For example, let us take, I'm writing a pi value, okay, so 3.14 something you are going to get like this, but those numbers are never going to get repeated. Like see this one, like you are going to get different kind of numbers one after other, but there is never going to be a cycle. But see here, what is 1 by 3? 1 by 3, you are going to get 0.3333. Even though they are not ending, you are getting the same numbers. So if there is a repetition, or if you can write them in the form of p by q, we are going to call them as rational numbers. Now, if you can't write them in the form of p by q, we are going to call them as irrational numbers. So, but remember one thing, 22 by 7 is a rational number, but pi is an irrational number. Okay, because 22 by 7, if you simplify it, after some digits it is going to get repeated, maybe 4 or 5 digits. But if you write pi, it's always going to be non-repetition of the pattern. Okay, so that's why pi is an irrational number, but 22 by 7 is a rational number. Now again, what are other classifications? See, you are going to have integers, whole numbers and natural numbers. Now, what are natural numbers? So simply saying the numbers you are using for counting, like 1, 2, 3, 4, 5, and so on. Remember, natural numbers are always going to start with 1. Not from 0, it's going to start from 1. Now, in natural numbers, again, we are having even numbers. even numbers are the numbers which you can divide with 2. Like for example, 2, 4, 6, 8. All these numbers are exactly divisible by 2. Then what about odd numbers, which are not divisible by 2? Or you can say, when you divide with 2, they are going to give you a remainder 1. For example, let us take 7. If you divide 7 with 2, you are going to get remainder as 1. So remember, all the numbers which are divisible by 2 are even numbers. All the numbers which are not divisible by 2, or you can also say, when you are dividing with 2, they are going to give you a remainder 1, are actually odd numbers. Now, one more thing. If you multiply any natural number, okay, with 2, you are always going to get even number. Like for example, 5 into 2, 10, even number, or 1 into 2, 2, even number, or 2 into 2, 4, even number. So if you multiply any natural number with 2, you are always going to get even number. That's why you are going to say 2n. Like n is a natural number here. Multiply with 2, you are always going to get even number. Then how to get the odd number? Simply 2n plus 1. Let us take 1. 1 into 2. 2 plus 1, 3. Like that. So all the even numbers are going to be in the format of 2n. All the odd numbers are going to be in the form of 2n plus 1. Then what is meant by prime numbers? See, prime numbers are always going to have two factors. Okay, one and itself. Like what is meant by factors? The numbers which can divide them. For example, let us take 5. How many numbers can divide 5? 5 can be divisible by 1, and 5 can be divisible by only 5. In both these cases only, you are going to get the remainder as 0. Those are the meaning of factors. If you divide a number with other number and it gives the remainder as 0, that other number will be a factor of the given number. So 1 is a factor of 5 and 5 is a factor of 5. So those are the only two numbers which will give you remainder 0 when you divide 5. Similarly, for all these numbers, okay, there are always going to be only two factors. The first factor is 1 and the second factor is the number itself. So prime numbers are going to have exactly two factors. So what are the numbers other than these prime numbers, or you can say which are having more than two factors? We are going to call them as composite numbers. Let us take 10. How many factors are there for 10? 1 can divide 10, 2 can divide 10, 5 can divide 10, 10 can divide 10. Like these are more than two factors. That's why we are going to call them as composite numbers. So I'm repeating once again. First, natural numbers. In that we are going to have even, odd, prime, composite. Okay. Now, what is meant by whole numbers? Simply saying natural numbers plus 0. Like in natural numbers, we are going to count from 1. And if you're counting from 0, we are going to call them as whole numbers. So 0 along with the natural numbers, we are going to call them as whole numbers. Now, then what is meant by integers? See here, if you observe, we are going only on the positive side, like 0, 1, 2, 3, but we are missing the negative. So all the negative numbers, 0, plus all the positive numbers. This set, we are going to call them as integers. So positive integers means starting with 1, 0 is 0, and negative integers are -1 to minus infinite. So this is the main classification of our numbers. Okay, let's move on to the next one. Now you all know these are formulas. See, when you are solving equations, or when you are solving algebraic problems, you can use these formulas to simplify. So when you are using simplification, you can use these formulas. Anyway, I will include them in the description. You can read them just to make your calculation somewhat better and faster. Now, coming to divisibility rules. As I told you in the PDF, you will have clear explanation. Here, I am going to tell you how you are getting them. That's it. Now, what is meant by divisibility rules? See, without doing the actual calculation, you can find out one number is divisible by the other number or not. So let us take, I am having 6, or let us take some bigger number, 128. I want to check whether this number is divisible by 4 or not. Divisible by 4 in the sense, if you divide that number with 4, are you going to get the remainder as 0 or not? That's what we are going to find out. If you are getting the remainder as 0, that means that number is exactly divisible by 4. Now, let us see the divisibility rules one by one. Let us start with 2. What is the rule for 2? So just to give you some, easy way of understanding, what I'm going to tell you is, I'm going to tell you a simple trick. So I'm going to write 2 as 2 power 1. How much is there in the power? 1. That means that if the last one digit is divisible by 2, that number is divisible by 2. For example, let us take 238. If you want to check whether this number is divisible by 2, you no need to do anything. Check the last one digit. Is 8 divisible by 2? Yes. Then 238 will be also divisible by 2. So for 2, you are going to check the last one digit. If that number is divisible, the whole number will be also divisible by 2. Now I will tell you why I am writing 2 power 1. Now, how can I write 4? 4 is 2 square. How much is in the power? 2. So use the same kind of rule as 2, but this time check last two digits. So if the last two digits are divisible by 4, then the entire number will be also divisible by 4. For example, I want to check 1, 2, 3, 4, 5, 6. Is it divisible by 4 or not? You no need to do the actual calculation. Just check whether 56 is divisible by 4 or not. Yes, then this number will be also divisible by 4. I'm repeating once again, divisible in the sense after doing the division, you are going to get the remainder as 0. Or let us take in place of 6, you are having 7. Then this number is not divisible by 4. So this number is also not divisible by 4. Let's go one more. What is 2 cube? 2 cube is actually 8. So the rule for 8 is similar to 2, but this time we are going to check last 3 digits. So if the last 3 digits are divisible by 8, let us take you are having a big number and check only the last 3 digits. If the last 3 digits are divisible by 8, then the entire number will be also divisible by 8. For example, 1, 2, 3, 4, 1, 6, 8. So if I want to check whether this number is divisible by 8 or not, I just need to check the last 3 digits. If 168 is divisible by 8, then the whole number will be also divisible by 8. So we're done with 2. There is last one number. For 4, last two numbers. For 8, last 3 numbers. Okay. Now let's go next one. Then what is the rule for 3? The rule for 3 is sum of the digits should be divisible by 3. That means let us take you are having 123. Okay, and you want to check whether this 123 is divisible by 3 or not. For that, add all the individual digits. 1 plus 2 plus 3. How much you are getting? 6. If this sum is divisible by 3, the number will be also divisible by 3. Simple as that. So let us take 231. Add all of them. You are getting 6. Is 6 divisible by 3? Yes. So 231 will be also divisible by 3. Then what is 3 square? 9. The rule for 9 is also going to be the same. The only difference is this time the sum has to be divisible by 9. For example, let us take 1, 2, 3 or 123. So if you add, you are going to get 6. Is 6 divisible by 9? No. Okay, that means that 123 is also not divisible by 9. Or I'm writing like this, 720. I want to check whether this number is divisible by 9 or not. Add all of them. Yes, 9 is divisible by 9. So this number will be also divisible by 9. For 3 and 9, you are going to check sum of the digits. Is sum divisible by 3? Is sum divisible by 9? So till now, we're done with the rules of 2, 4, 8, 3, 9. Now let's go to the next number, 5. What is the rule for 5? Simply, see, if you check the 5 table, 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20. Yes, sir. See, always we're ending with 5 or 0. So if the last unit digit is, or last one digit is 0 or 5, then only that number will be divisible by 5. That's what I'm writing here. If the last digit is 0 or 5, then that number will be divisible by 5. Next, then what is the rule for 6? See, 6 can be written as 2 into 3. Okay. So if a number is following both the rules of 2 and 3, that number is divisible by 6. For example, let us take 18. Is 18 following the rule of 2? Yes, because the last number is divisible by 2. Is 18 following the rule of 3? Yes, 1 plus 8 equal to 9, which is sum is divisible by 3. So if a number is following both the rules of 2 and 3, that number will be divisible by 6. Okay, now what is the rule for 7? See, the rule for 7 is kind of tricky, but it is similar to the rule of 19 also. We'll see. See, let us take, I'm having 7, 1, 4, 7 like this. I want to check whether this number is divisible by 7 or not. Simple thing. Let us take the number is ABC. What you have to do is take the last digit and multiply with 2. That means making it double. Whatever the remaining number is there, subtract this doubled number from them. So if you make the D double, the remaining letters are ABC. If the difference between this ABC and this 2D is 0 or multiple of 7, like 7, 14, which is a number divisible by 7, then that number will be divisible by 7. So I know it is kind of confusing for you. Let's go one more time. Okay. For example, what is the last digit here? 7. Make it double. How much you are going to get? 14. But let us take the previous number first. 7, 1, 4. Make it double. It's going to be 14. Subtract it. 700. Is 700 divisible by 7? Yes. Then this number will be also divisible by 7. Take the last digit, make it double, and subtract from the remaining digits. If the answer is divisible by 7, okay, if the answer is divisible by 7, then the given number will be also divisible by 7. I hope this one is clear. Last number, make it double, subtract, answer has to be divisible by 7. Now the question comes, what if we are having some bigger numbers where I can't get the answer in single step? Then you can apply them again and again until you are satisfied or until you are comfortable. For example, let us take a bigger number, 714. No, let's make it 7714, because last time we got exact 0. So 7714. Let us take. I want to check whether this number is divisible by 7 or not. What I'm going to do, I'm going to make it double first. So subtract from the remaining numbers. 4 to 8. Now check how much you are getting. See, this is 3 and this is 6 and this is 7. You got 763. But still, 763 is also somewhat bigger number, where I don't know whether that is divisible by 7 or not. You can apply the rule once again. That means take the last number, make it double. 76 minus 6, 0, 7. So yes, this number is divisible by 7. If this number is divisible by 7, then the number formed because of that one will be also divisible by 7. So if this is divisible by 7, the cause number will be also divisible by 7. What I want to say here is, if you can get the answer in a single step, that's good. But let us take, you are taking somewhat bigger number and you are again getting some big value. Then you can apply the rule once again to make yourself comfortable. You can repeat the process as long as you want. There is nothing going to be wrong. Okay. Sure. Next one. Next, why I said it is similar to 19. See, the rule of 7 is you are going to take the last number and you are going to make it double and you are going to subtract that from the remaining numbers. The answer has to be divisible by 7. But for 19, the same process, but this time we are going to add it to the numbers, make it double. So you have to add them to the remaining numbers. If the answer is divisible by 19, then the number will be also divisible by 19. For 7, we are going to subtract. For 19, we are going to add. Then, what about 10? We know if the last one digit is 0 or last unit digit is 0, that number is divisible by 10. So we are going to discuss one more, that is 11. 11 is kind of a simple one. See here, 121. So I'm going to write 121, 121. So I want to check whether this number is divisible by 11 or not. So the 11 is very simple. Add all the odd places numbers. Add all the even place numbers. If the difference between them is 0 or some multiple of 11, like 11, 22, 33, then that number will be divisible by 11. What is meant by that? Identify all the even place numbers. 1. Even places means second place, fourth place. Odd places means first place, third place. Remember, not odd numbers, it is odd places. Like first place, third place, fifth place. These are odd places. Even places are second place, fourth place, sixth place. Add all the numbers in the odd places, add all the numbers in the even places. See here. 1, 1, 2. We got 4. 2, 1, 1. We got 4. The difference has to be either 0 or some multiple of 11. Then this number will be divisible by 11. Add all the odd places numbers, add all the even places numbers, subtract one from the other. The answer has to be 0 or some multiple of 11. Okay, that's what I've written everywhere here. And remaining numbers I have mentioned in the you know PDF. There you can go through. Okay, now before moving on LCM and HCF, I will tell you one more. This is important. Okay, let us take, you want to find out whether a number is divisible by 18 or not. For 6 we have simply written 2 into 3. Yes or no? But here 18 we can write it as 2 into 9 or 3 into 6. Which pair we have to select? This one or this one? Which one we have to select? So there, if you are getting more than one pair like this, you have to check for co-primes. Guys, remember, co-primes are not prime numbers. Okay, co-primes means for the pair which is having LCM is equal to product of the numbers. Okay, and HCF equal to 1. I will tell you what is meant by LCM and HCF now. But LCM means it has to be LCM. If you calculate LCM, it has to be product of the numbers. And when you calculate HCF, it has to be exactly 1. Now in these two, if you find out, okay, LCM of 3 and 6, you are going to get 6, which is not product. But if you find out LCM of 2 and 9, LCM of 2 and 9 is actually equal to 18, which is product of the numbers. And if you find out HCF, you are going to have only 1. That's why you have to check the rules of 2 and 9. If a number is satisfying both the rules of 2 and 9, then only that number is divisible by 18. Okay, let's go. Next one. So what is meant by LCM and what is meant by HCF? Okay, so you can read the definitions from the PDF. I will explain what is meant by what. See, least common multiple. So first three, what is meant by multiples? Okay, now listen guys. If you take 2, what are the multiples of 2? 2, 4, 6, 8, and so on up to infinite. Now remember, multiples are always going to be equal or more than the number. Then what are those multiples? Multiples are the numbers which are divisible by the given number. Remember the word divisible. Divisible by the given number. See, is 4 divisible by 2? Yes. Is 8 divisible by 2? Yes. So multiples are the numbers which are divisible by the given number. Then what are the multiples of 6? So all the numbers which are divisible by 6, like 6, 12, 18, and so on. So remember, that's out. Now the question itself. What is the least common multiple? So to understand that, let us take more than two numbers so that you can easily understand what is the meaning of this. So I'm going to take like 4, 6, and 8. Let's find out the multiples of 4 and 8, 6 first. We're going to discuss LCM first. So the multiples of 4 are 4, 8, 12, 16, 20, 24, and so on. Okay. What are the multiples of 6? 6, 12, 18, 24, 30, 36, and so on. 8, 16, 24, 32, and so on. Now see here, we are done with the multiples. What is the second term? Common. Identify the common numbers. Okay. So if you observe here, so is 4, 6, 8, we're having common at 12 is not here. 24, yeah, see here, 24, 24, 24 is common. If you continue the cycle, again you are going to get 48 in all of them, which is the second common one. So first multiples, then we identify the common ones. Then the least one. What are the least one here? 24. That's why LCM of 4, 6 and 8 is actually 24. Out of the multiples, out of the common one, what are the least one? Now, why we need LCM? See, that means 24 is the smallest number possible that can divide all the given numbers. It can divide 4, it can divide 6, it can divide 8. So 24 is the smallest number which can divide all the, which is divisible by all the given numbers. It is divisible by 4, divisible by 6 and divisible by 8. So to find out a number which is divisible by the given numbers, we are going to use LCM. Now, what are the drawbacks of using this method? And one more thing, you may have never heard this word, HCM, highest common multiple. Why? This is going to continue until infinite. You can't find out the highest multiple ever because every number is going to be higher than the previous one. You can never go to the end. That's why whenever you see the problems on least variables, that's always an LCM problem. So least common multiple. Now, what are the drawback of using this technique? The problem of writing all the multiples here is, let us take you are having some very large numbers like 140, 150 and 176. Who is going to write the table of 176? That is going to be too big. That's why this technique you can use only when the numbers are too small. If the numbers are bigger, we are going to use some other techniques. Okay, let's go to them. Now the second one is prime factorization. That means write all the numbers, okay, in terms of prime numbers as a product of prime numbers. For example, let us take 4. 4 can be written as, okay, 2 into 2. 6 can be written as 2 into 3. And 8 can be written as 2 into 4, or it can further simplified as 2 into 2 into 2. Why? 4 is not a prime number. So write all of them as a product of prime numbers. Now next step. What are the numbers you are seeing in all of them? So I'm seeing 2 here, I'm seeing 3 there. So take every number and take their highest powers. That means here in this multiplication, 2 power highest is 1, but here 1 and 1. But here 2's highest power is 3. Like how many 2's are there, how many 3's are there, that much power. So here take the highest power in all of them. So here what is the highest power of 2 here? 3. So let's take 3. Multiplied with what is the highest power of 3? See, 3 power 0, nothing is there. 3 power 1, 3 power 0. So highest power of 3 is 1. Now, if you multiply them, you will get your LCM. So 2 power 3 is 8, 8 into 3, 24, which is the same answer. Remember, all the terms, like even 3 is present in only one number, you still have to take that one. That's the meaning of all the terms with their highest power. Okay, all the terms with their highest power, multiply them, you will get your LCM. Now, what is the drawback of this one? The drawback of this one here is, what if the number is like 1, 2, 3, 4? You are going to get very large multiplication here, like 2 into 3 into, 7 into 9 and something like that. It's going to be too lengthy. Then writing this will be also difficult. That's why we are going to use one more technique that is called division method. So in division method, what we are going to do here is, let us take 4, 6, 8. Take a prime number, 2. Divide all of them. Is how many times you can cancel 2 in 4? 2 times. Here in 6, 3 times. Here 4 times. Again, do one more time. You have to do like this until you get all prime numbers are all ones. So here one time. Now, if a number is not divisible by 2, drop the number as it is. 3. And here again 2 times. Now see, all we got all different numbers are all prime numbers. Just multiply them. All ones are all prime numbers. Anything is fine. So you are going to multiply like this in order. 2 into 2 into 1 into 3 into 2. Multiply all of them. You will get your LCM. The reason why this is best here is, every time we are doing 3 divisions simultaneously. Instead of doing 1 by 1 division, we are doing 3 divisions. So every time that's going to reduce by 3 times. It's going to be much better. So what we are going to do? We are going to divide the number with prime numbers, and if the number is not divisible, we are going to drop it as it is to the next cycle. And we have to repeat like this until you get all ones, all prime numbers. I mean, there is no common multiple between them, like those kind of numbers. Okay. And at the end, multiply all of them, you will get your LCM. Okay. Now, you can see the same here. What will be least common multiple of 4 and 6? And now we are going to discuss about why it is 4 and 6. See here, simple thing, 4 and 6, 2 here, 2 times, 3 times. Both of them are prime numbers. We can't go further. So 2 into 2 into 3. That is 12. Now let's discuss about HCF, highest common factor. Highest common factors. Now listen, multiples are always going to be equal or more than the given numbers. And the factors are going to be equal or less than the given number. That means, what are the factors of 10? 1, 2, 5, 10. So what is meant by factors? The numbers which can divide 10. Okay, divide 10. That means that, let's take, is 10 can be divisible by 1? Yes. Is 10 can be divisible by 2? Yes. So all these numbers can divide 10. That is the meaning of factors. Okay. Remember, in multiples, we are going to say divisible. For example, if I want say 10 multiples, 10, 20, 30, all these numbers are divisible by 10. But all these factors can divide 10. There is a difference, divisible by and a divide. Understand that one. Okay. Now let us take the same example. We have taken 4, 6, and 8 previously. We take HCF of them. First, we are going to write factors. What are the factors of 4? 1 is there, 2 is there, and 4 is there. What are the factors of 6? 1 is there, 2 is there, 3 is there, and last one, 6 is there. What are the factors? See, all the numbers which can divide 8. 1 can divide 8, 2 can divide 8, 4 can divide 8, and 8 can also divide 8. So we're done with the factors. Identify the common ones. 1, 2, 1, 2, 1, 2. Those are the common ones. And what are the highest? 2. So HCF of 4, 6, 8 is 2. That means that if you take 4, 6, 8, the only highest number which can divide all of them, like 2 can divide 4, 2 can divide 6, 2 can divide 8. So the highest number which can divide all the given numbers is nothing but 2. Now, why we are not saying the word LCF? Why least common factor? Why? Because for least common factor is always going to be 1 for all the numbers. That's why whenever you see the word highest, that is HCF problem. Whenever you see L, that is lowest, that is LCM problem. Because LCM, you can find out lowest. See here, for LCM, you can find lowest, but not the highest. Why? Highest is always infinite. For HCF, you can find out highest. Why? But not lowest. Why? Lowest is always equal to 1. Okay. See, and one more thing. If I say multiples of 10, sorry, multiples of 8, 8 is going to be in the denominator. So what are the numbers multiples are going to be the numerator? But if I say factors, okay, whatever the number you are taking, that has to cancel 8. So that's going to be in denominator, 8 is going to be in the numerator. So have this some idea. And remember one last thing. Product of the terms is always equal to product of their LCM and HCF. For example, product of LCM and HCF is always equal to product of the terms. Okay, like for example, 4 and 6. What is the LCM of 4 and 6? You are going to get 12. What is the HCF of 4 and 6? You are going to get 2. Multiply both of them. 12 into 2, 24. 4 into 6 is also 24. So product of LCM and HCF is always equal to product of the terms. And the next one. So here, what to do, like if you're having fractions, let us take I'm having 12 by 3 and 7 by 5. How to find out LCM of fractions? Then it has to be LCM of the numerators by HCF of denominators. Similarly, for HCF, it's going to be reverse, like HCF in the numerator and LCM is going to be in the denominator. That was here. So let's go to the notes and check once. See, first we have the natural numbers. What is the definition of natural numbers? Odd numbers, prime, even, composite, whole, integers, rational, irrational. We got everything here. Okay. Then we got all the divisibility rules like 2, 4, 5, 6, 7, 8, 9, 10. We covered everything. Yeah, we got everything here. And the rule for 25 is no, the last two digits are 0 or 25 multiples 25, 50, 75. These kind of numbers, that number is divisible by 25. Then we got LCM. How to find out use LCM using definition, then using division method, and again using prime factorization. And here this is division, what I did in brackets. Then HCF, what is the definition, and how to find out using division method, and how to find out using factorization method. Everything is there with explanation step by step. Okay. And finally we got these two. LCM of into HCF of two numbers is equal to product of the numbers. Then how to find out for fractions. Okay, so everything is there. Yeah. So see here 4 by 9 and 6 by 5. So HCF of like C, A and C, and LCM of denominator B and D, like that. The next we are going to cover power cycle and remainder cycle. Okay, let's go. Thank you.